Another powerful example of how aging reflects nutritional inadequacy rather than intrinsic disease is the progressive decline of autophagy, the body's essential cellular cleanup system. Autophagy enables cells to degrade and recycle damaged proteins, organelles, and other cellular debris, maintaining internal quality control and metabolic efficiency. When autophagy falters, these dysfunctional components accumulate, contributing to widespread cellular dysfunction and inflammation, both key drivers of age-related decline. Yet, what is often overlooked is that autophagy is tightly regulated by nutrient-sensing pathways, particularly those responsive to amino acid availability, including the mechanistic target of rapamycin, mTOR, and AMP-activated protein kinase, AMPK. Adequate dietary protein intake, providing a complete profile of essential amino acids, is critical for sustaining healthy autophagic flux. While periods of amino acid scarcity can transiently trigger autophagy as a survival response, chronic low-protein diets paradoxically blunt autophagic efficiency over time. This is because prolonged amino acid shortfall disrupts the cyclical regulation of nutrient-sensing pathways that coordinate the balance between autophagy activation and synthesis of new cellular components. Without sufficient protein, the machinery needed to rebuild after autophagic recycling simply isn't there, leading cells to abandon this maintenance cycle altogether. Evidence shows that elderly individuals with chronically low protein intake exhibit markers of impaired autophagy, including the buildup of dysfunctional mitochondria and protein aggregates within muscle and neural tissues. These accumulations are directly linked to sarcopenia, neurodegeneration, and metabolic disorders, all hallmarks of aging often interpreted as inevitable disease processes. By contrast, maintaining adequate protein intake in older adults supports autophagy's vital role, reducing the accumulation of cellular waste products and preserving tissue function. Moreover, dietary patterns that ensure balanced, high-quality protein consumption, such as Mediterranean, traditional Japanese, or Nordic diets, are consistently associated with slower onset of age-related decline and better maintenance of muscle mass, cognitive ability, and immune competence. These populations demonstrate not only longer lifespans, but also extended health spans, reinforcing the central role of sufficient amino acid availability in supporting autophagic processes. This understanding powerfully reframes declining autophagy with age. Rather than seeing it as a genetically programmed disease, it becomes clear that it represents the predictable consequence of a failure to meet the body's basic nutritional needs. By correcting chronic protein insufficiency and optimizing amino acid intake, individuals can enhance autophagic efficiency, limit the buildup of cellular debris, and preserve resilience against the stresses of aging. Ultimately, viewing impaired autophagy as a preventable, malnutrition-driven breakdown rather than an inescapable hallmark of aging empowers us to act. It underscores that nutrition, specifically adequate, balanced protein, is a foundational lever to maintain the cellular recycling mechanisms that keep tissues youthful and functional, redefining aging not as a disease, but as a modifiable process responsive to lifelong dietary habits.